again, introduce a business scenario that will carry us through the next few classes as we flesh out a complete app. So thanks for starting the transcription and recording, Rakesh. I would have completely forgotten it had you not done that. Then we would have had to do this all again. So next week we'll continue building out the app. We'll get into building some pipelines and adding some other things later on. I think the business scenario we'll talk about, and I think it lends itself to adding on lots of little extra things that we can learn from. So go from there. So just to recap from last week, we talked about two general kinds of models: diffusion, which is good at generating media, and LLMs, which is good at generating language. So those are kind of our two big types of large scale models. There's lots of other models in the machine learning universe. We're using lots of them at Viore, regression models, time series models, things like that, that they're not as big. They don't take up billions of parameters. They're relatively small. They're more mathematical. And so we're kind of segmenting this course into the LLM world. We may go back into the diffusion models at some point if we want to do some media generation. I think we'll do that at some point. I've got a great exercise from a class that I took where we actually build a diffusion model from the ground up, and we teach it to recognize pictures. Is this a cat or a dog? And when you can give a nervous breakdown by showing it a fox. As one of my friends said, a fox is just a dog running cats, dog hardware running cat software. So a fox kind of falls right in between. So it's kind of fun to see what it decides. But you can build. We can do that when we get down into some advanced topics of actually creating neural networks from scratch and then training them. So the training is where the interesting stuff comes, getting enough training materials and so on. So first part of the course, we're going to focus mostly on using LLMs and maybe diffusion models. Later on in the course, we'll possibly get into some more advanced topics as the class develops. I kind of am, in discussion with a few people, I kind of foreseeing this as being kind of an ongoing thing. As interesting topics come up, and there's a million interesting topics in this area, we can just have classes every Friday to learn new things, and then record them, and people can catch up as we go. So finally, the last thing we showed how to run LLMs locally, and also how to access some of the cloud providers. I know, Chris, you use Grok. Did you run into any issues there?
No issues at all.
Cool. I'm going to be using Grok today because it is very fast and it's free. And it also runs my current favorite model, which is GPT-OS S20B for free. So I can run GPT-OS S20B on my laptop. I have about 24 gig of RAM, so it's not a huge laptop, but I think if you have only 16, that particular model will be just a little bit too big to run. But it seems to be a very fast and capable model that pretty much will be able to do everything we need in this business scenario. So that said, we got all that installed and tested. Did anybody try any other models or any other LLM providers? I'm not seeing any flickers of recognition. Rakesh, go ahead. Or
I applied like before some models from Olama.
Okay.
Not this week.
Okay. Yeah, and you can use Olama as a provider here. Instead of LM Studio, Olama works fine to serve up the models. So we've got lots of choices both locally. There's probably 4 or 5 good model hosting things you can run on your laptop. There's Llama CPP, which is actually the one of the underlying engines of LM Studio. There's VLLM if you're on a Windows machine. A lot of people really like that. I think it's a research project that came out of Stanford. Um, and then there's our LM Studio, there's Olama, and I'm sure there's 25 other ones. And if you've got a pile of Macs sitting around, old Macs sitting around, there's a library called EXO that will allow you to network all the Macs together and share a model across multiple Macs. So if you want to run DeepSeek 650 billion parameters, you can go to your closet and get out a bunch of old Macs and thunderbolt them all together, and it'll sort of uh, run a big model.
That sounds
I
like a
haven't
LAN
seen.
party.
Yeah, it's like a LAN party exactly. Back at these kids are too young to know what a LAN party is, but uh, so a couple some terms. I threw this in the slide, one of the slides from last week, but we didn't get to it. I don't want to spend a huge amount of time on this, but a few terms that are good to know that get thrown around in the AI world. We've got MOE, that's mixture of experts, and GPT OSS 20 and 120 are both examples of this. Essentially, what it is, it's underneath when you call the LLM, there's actually potentially 8 or 16 submodels inside the LLM. And so for efficiency, there's a router on the front. And when you ask a question, the router will decide which of the sub models to activate. So the models are typically trained with some expertise in different areas. Maybe there's a scientific one, a math one, a general knowledge, etc. The router will look at your prompt and decide which of the sub models it will activate. And usually it activates somewhere between 2 and 4 models. What this gets you, it doesn't really save you any memory, but it saves computation time because only the models that are activated will have computation going on during the inference. So it can be highly efficient and faster. So a lot of the models these days are doing that. GPT OSS, the nomenclature, the name of the model doesn't tell you that it's a mixture of experts, but if you look at some things like Mixtral, it'll say 8x 16 or something like that. That means there's 8 models, each of which is 16 billion parameters. So next we have RAG, which is retrieval augmented generation. This is something we'll be doing later, a few weeks from now, to augment our app. We're going to learn about vector databases where you search not by a traditional database key, but you search by meaning. So what we can do is use a vector database to take like extremely large documents. Let's say we have some computer manuals that tell you how to connect a printer, or company policy documents or things like that. We can take those and turn them into smaller pieces, each of which is assigned a semantic vector that encodes the meaning of that chunk of the document. Then when we type in a prompt, we run that prompt through the same vectorization process, and then we can search for the vectors that are keys in the database that are closest to our prompt and return maybe the 5 pieces of the document that are the closest to our question. And we feed those in with our prompt as context. And we can say, answer the question that I'm asking and only use the documents that are provided. So it prevents the LLM from hallucinating. I'm sure you've heard about some of these stories where people have, especially seems to be affecting lawyers a lot, where they go in and they tell ChatGPT to write up some notes for the case, and the LLM will make up citations of law that don't exist. Well, you can prevent that by giving it the documents you want it to consider. So RAG is an extremely valuable uh, process when you're dealing with huge amounts of external information that you want the system to consider. So vector DB, that's the next thing. Again, we collapse the text. Maybe we take chunks of the document that are 512 words. We collapse that into a vector using an embedding model. They're very cool. They're very small. You give it a chunk of text and it returns like a 368 or 512 number vector. And that is the meaning of the text. So kind of fun stuff. Very, very, very interesting things to play with. Next one is LRM. So this is a branch, I would say, again, we'll see today we can actually control how much thinking it does about the problem that we present. So reasoning models have been tuned to think step by step and to talk to themselves, if you will. So instead of just bang answering your question, it'll develop a series of steps to think about as it answers your questions. A year ago, 2 years ago, we did this manually by using what's called chain of thought prompts. We would tell it to do this explicitly in our prompt. Like we'd say, I want you to solve this problem and I want you to think carefully step by step. Well, now that's built in through the reinforcement learning process and the fine tuning. It will just do that automatically. The nice thing about some of the newest models is you can control that. So it used to be you picked a model that did deep thinking or not. Now with GPT OSS and a few of the other models, we have a parameter. We can say minimal reasoning, medium reasoning, high reasoning. And depending on the complexity of the problem, we might choose different levels because it's a speed versus accuracy trade-off. Another thing we'll get into in the course later on are agents. These are like little mini reasoning models typically, or they may actually be deterministic functions, but they're built in such a way that an LLM can use them. And again, one reason I'm using GPT OSS a lot, it is a model that's trained to use tools of which the agents are an example. So maybe we have our model and we want it to predict some retail store foot traffic. Well, one thing we want to know is for a particular store in a particular area, what is the weather prediction for this weekend? We're running a store. We want to know how many people to come in to staff the store this weekend. Well, if it's going to be a rainy day, maybe historically we know that a lot of people will be at the mall shopping because they can't be outside. So we can create an agent that the LLM can talk to and have it go get the weather forecast. And the LLM can just say, my store is in this city. Go get the weather forecast for the next 3 days for this city, bring it back, and I'll use that in my consideration of the question. So we'll build some agents later on. And we do that using a thing called MCP, Model Context Protocol. It's something that Anthropic came up with over the last year or so. It's a very standardized interface for calling models from within an LLM. So again, this will be when you pick an LLM for your project, if you're going to use tools, you have to make sure that it's an LLM that can call tools. Not all of them can. So it has to be trained again in the post large scale training, do some reinforcement learning. It'll be taught how to call a tool and what MCP protocol is. And then lastly, a couple little high level things. CUDA is basically an ecosystem that NVIDIA represented. One of the reasons NVIDIA is on top of the world in terms of AI and their chips is not so much the hardware. There's lots of hardware that's just as good, but it's their software environment. And you'll find that CUDA is pervasive and other hardware has not caught up yet to the CUDA software environment. That's what's giving NVIDIA their huge edge in adoption. Apple has a version basically called MLX. Down deep, what these libraries are at the core are matrix operation libraries. So if you remember your linear algebra courses from college, they're just doing matrix multiplies, heavy duty in parallel, lots of optimizations. That's what's happening down at the core level. So an NVIDIA chip or the neural processors at Apple, at the base of it, they're just doing matrix operations, mostly multiplications and additions. Then we build functions on top of that that do cooler and cooler things. MLX works pretty well on Apple hardware, and they're actually coming out with a version that acts the same as CUDA. So basically, they're trying to. I think we're going to see the world sort of unifying around CUDA as a language ecosystem. It can be used from Python, it can be used from C, etc. You can use it for pure math. You know, if you're it's not just for AI, it's for math as well. AI is built on top of the math functions. So those are some terms we'll be referring back to occasionally during the course. So let's jump into our business scenario. We're gonna be working for a company called Prestige Worldwide. And Prestige Worldwide, it's a medium-sized company, about 5,000 employees. It's got offices mostly in North America, Western Europe, and Latin America. That'll become important in a minute. So they have a broad range of services. They sell some products, some tech products. They offer some consulting services. They've got financial services, etc. So there's a wide variety of things they're dealing with. So our particular problem or our particular area is that employees and external customers can submit support tickets for the products they're using, or internal issues. They've got consulting customers that they're helping. So they've got a whole bunch of different kinds of support tickets coming in. Second issue is that the employees and customers are going to be writing in their home language, which is we'll have about 5 languages: English, Spanish, French, Portuguese, and German are the languages that we're dealing with. We've got Portugal in Europe. We've got Brazil in South America, which are big markets for us. We've got German, French. We've got a variety of French-speaking places around Latin America as well, and Spanish, of course. So we've got to be able to deal with all these tickets coming in, regardless of the language they were written in. And of course, our team is all sitting in America right now, and so they deal mainly in English. We've probably got a couple Spanish speakers on the team, but that's not going to be, totally true of everyone. So someone's got to translate these tickets. Someone's got to categorize them. So there's a lot of humans in the loop here that are slowing the process down. Translation takes time, categorization takes time, prioritization takes time. So let's work through some of the pain points. We've got a high volume of tickets coming in. It's unstructured data, so a human has to read through it. It's just an email. There's no fields in particular. We have a very crude support system. It's just incoming emails. So we've got a subject line and we've got a body of the email where the person requesting support is just going to describe their problem. Again, very, very simplistic. We have multiple sources of tickets. It could be from internal people struggling with our own IT infrastructure. It could be external customers who need product support. It could be consulting customers that are requesting work be done, etc. And again, we've got a variety of languages coming in to deal with. So our problem is we got a big backlog of tickets. Probably we've got thousands of tickets coming in. Again, there's a lot of human touching that has to go on with these tickets before they can actually be worked on. Also, another problem is because different people are looking at these tickets, we're getting different prioritization. People are using their own judgment to prioritize how important a ticket is, and we prefer to have a standard set of rules applied. So we're going to use these sorts of pain points to think about what we can do for the company to speed up the process and to make it easier and to allow the team to work on tickets rather than spend their time doing these other tasks like prioritization and such. So let's break down the project into some overall goals. So we're going to spend a fair amount of time today just understanding the problems so that we can see where we can leverage our LLMs. So what are the business goals? How will we measure success? What are the ticket sources? What are the requirements for multilingual? We got to think through those. How do we categorize things? How do we route them? How do we assign priorities? Where do we where do we still need humans in the loop? Or are we just going to blast through this and hope for the best? Are we going to do integration? Where the tickets come from? Where do they go to? How do we train and test? How do we make sure our system is working? What are the risks? How do we fix misrouted tickets, misprioritized tickets? And then how will we monitor performance in the long term? Anybody have any other thoughts? Am I missing anything here? Is there anything else that we should be thinking about? Everybody's satisfied? All right, let's dive in. So I kind of asked the questions and answered them myself, more or less. So what are the top business outcomes we should achieve? Well, our number one goal is to reduce the time that tickets spend waiting for assignment. And by that, we're going to reduce the amount of labor, and we're going to increase the amount of tickets that are correctly categorized and prioritized. The idea being we're going to get whoever's requesting support, they're going to get their answers faster. They'll be more accurate, and they'll be assigned to the right team on the first go. We can measure our success by tracking, how many tickets had to be recategorized, how many hours we saved. Now, we have a made up scenario here, so some of this data really isn't available to us, but we can imagine that if our LLMs are classifying things in 2 seconds and it took a human 30 seconds to read an entire email and decide, we can see that pretty clearly we're going to get some speed up there. We may not be able to calculate an exact percentage with our sample problem, but we should be able to see how fast things go. So again, the big goal is accuracy, better accuracy, more consistent assignments, and an overall reduction in the amount of time it takes from intake to getting it into a queue to be worked on. We aren't speeding up the work at this point, but we are speeding up the assignment. Later on, maybe we'll get into some, ability to do automatic answers for simple questions. That's where we'll start to get into retrieval augmented generation, where we have company documents. Maybe we have a document on how to properly connect a printer. If a question comes in, how do I connect this printer to my PC? We might have a document already that has that. We might have a customer service system that has lots of tickets that have already been answered in it, and we can use that as sources of automatically answering. So we'll need a curated source of correct answers in a sense, and then we could possibly automatically answer some of these questions. So again, the idea is this: we're going to tackle just a couple simple things here right now, but this is a problem that we could really continue to work on for many weeks. So where our tickets come from, they're all here to us as an email, but they could be generated from our website. There could be a form that someone fills in. They come from our customer or facing website. Maybe they're general questions about what we do for consulting. We have internal emails requesting support. My printer doesn't work anymore. We have customers, we have third-party integrations that might be feeding us things from other systems. But they're all going to appear to us as emails. We've sort of decided that everything, our interface with the outside world is just emails. So we're not going to worry about actually integrating this yet. That's really, probably going to go to a different group. We're going to be the AI guys. We're going to solve the problems that AI can solve. The digital engineering team will probably be the guys that hook up the plumbing. So we would, in the real world, we'd be working with them to make sure that the plumbing was set up, that we were getting a good flow of the emails, and our answers were going back to the right place. So we're going to let that team worry about that stuff for today. We're going to work mainly on our expertise, which is the LLM stuff. So we know that a lot of the tickets will be coming in various languages. We've outlined 5 languages: Spanish, French, German, Portuguese, and English. Our team only speaks English or predominantly English right now. So we're going to want to bring everything in and translate it into English and then assign it so that it goes into the queue in English. One thing we want to do, though, is we probably want to track the original language so that downstream, when the team answers the question ultimately, we're going to want to translate that back into the source language. I think it would be polite to answer the originating questioner in their home language. Another thing we're going to possibly want to do, maybe we won't do that today, but down the road, we may want to make the English output, we might want to make that a parameter. So that if, let's say, we move our support team to India, maybe we have a team that mainly speaks Hindi or one of the regional languages. We might want to change the language we translate into so that the team can be the most comfortable dealing with the ticket and then translate it back when we're done. So that will, if we're going to do that down the road, we may need to choose different LLMs. And you can actually go sometimes to the model card. I showed you the model card on Hugging Face. GPT OSS 20 and 120 have extensive model cards that talk a lot about how they're built, and they talk about what languages they're trained in. So GPT OSS isn't trained in every language. It's trained in maybe 12 or 14 languages, at least the 20 billion parameter model. Turns out, I believe Hindi is one of those, but probably not the regional languages of India. So the reason we want to think about this as a requirement is if we're going to have to, if we move our support team to Indonesia, we may need a different model that's going to do the translation into one of their languages. So moving along, so how are we going to categorize and route? Well, after doing a little bit of poking around with the tickets and our own system, we basically divide the tickets into 4 basic categories: an incident, a request, a change, or a problem. These are kind of, I'm not in love with these categories, but that's what the original, that's what the system we're dealing with wants to see. We also have to put it into a destination queue. So we have different departments that will deal with different kinds of problems. So billing and payments, customer service, general inquiries. So this might be from the website. Hey, do you guys do network support? We have internal human resources. Hey, my paycheck didn't arrive, or I got paid 10 times too much. Who do I report that to? That'd be a pretty rare one, I think. IT support, product returns and exchanges. So we've got a lot of different things coming in. We need to sort of categorize what queue we're going to put that in. We can ask the LLM to do things like only put this in a queue if you're at least 90% confident. Another option we could have is if you're not 90% confident, let's set a flag on this one that it needs human review. Maybe we can guess, or we can say if we're not really sure, we're going to kick this out into a special queue for human review. So that's pretty typical. So now we're talking about, I guess the terminology would be human in the loop. So we could even have a human, probably in the early going, we're going to want a human to double check all assignments for a while. Maybe during a pilot phase, we take 10% of our tickets, we put them into our system, we do all of our LLM assignments, and then we have a human review them, and they can judge the quality. They're going to say, this was correct, this was incorrect. That can be feedback. And we may have to adjust our prompts, try a different model, etc., to get better scores. Priority levels and escalation. We need to understand how priorities are defined. Are there SLAs documented? And created one on the next slide so we can see. But what are we going to look for in the email? What signs of urgency? Uh, Maybe subject line keywords. There's an outage. I can't log in. My payment failed. This is a great job for an LLM to interpret these. I wouldn't call them emotional type things, but urgency is certainly a good word. If we're uncertain again, we may kick these out to the human in the loop. Um, so for purposes of our exercise now, I created a quick set of rules for priority assignment. So we have a pretty simple priority system: P1, P2, and P3. P1 basically critical. Uh, Probably more than one person is being blocked by something. There's a security issue. Our payment system is down, so we're not getting money in the door. Certain things are like priority one. These have to be resolved instantly or sooner. So a whole department is blocked. There's a company-wide outage. We're missing revenue, or it's a security breach. P2 is more of a medium impact. It's a small team or a single user is blocked, but they have a hard deadline. I can't, my Teams isn't working and I have a presentation in a half hour. These sorts of things would be escalated. Low service on something that's shared across the entire company or a big department, things that are affecting multiple users, or a locked account, etc. Things that are preventing our employees from doing their work. And then finally, minor, more like informational requests for a quotation on price, cause feature requests, etc. Not things that aren't blocking usage, and there's no particular deadline. So things we definitely want to fix or get back to, but they're not necessarily high priority. So again, we want to also decide in our workflow, are we going to have humans in? How deeply involved are humans? This is probably going to be a sliding scale pilot program. We're going to want to review everything and grade the LLM's work. Later on, hopefully, we'll let the LLM take over more and more of the things automatically, and we'll continue to monitor them. People that are in the receiving queue are going to kick back things that are not for them. They're going to adjust prioritization if they think it's different, and all of that should flow back to us and allow us to monitor. And if we start to see large numbers of reassignments and large numbers of corrections, reprioritizations, we're going to want to take note of that and make some adjustments, probably in our prompts. But there's lots of different things we can tweak. Again, integration considerations, we're just not going to focus on that here, but in the real world, I think Chris can probably attest to this. This is a huge part of the effort, is getting the plumbing right, making sure the stuff is flowing, monitoring to make sure there hasn't been a disruption upstream. Our system would need to raise its hand if it went an hour without seeing any tickets or something like that. So there's lots of stuff here that would have to be built in. At Viore, we're going to kick that over to Dave, probably Dave and Jeff, maybe. We've got a team that's going to build that plumbing for us, and we're not going to worry too much about it, but we may have to take it into consideration in terms of monitoring. And finally, one of the biggest issues we have is what data do we have to work with? Do we have test data? What does the data look like? And so I sourced from a website called Kaggle. Some of you are familiar with that. Kaggle because it kind of started out as an AI machine learning contest site where people could post problems and have people compete to see who could do the best job solving the problem. I think one of the very first ones they kicked off with was a very famous problem where they have all of the data about all the passengers that were on the Titanic when it sank. And your job is to take all of that data and predict who will live and who will die based on what class their ticket is, where on the ship was their room, whether they're male or
Gender.
female,
Yeah.
gender, age, etc. And it's a very messy problem because weren't clean categories of survivors. There were, the old thing of women and children first was certainly mostly observed, but then there were lifeboats that were ready to launch and they weren't full, so a bunch of men got on. There were men dressing up as women. There were kids dressing up as littler kids. So it's very messy data. So there's no possible way to get a perfect prediction, but you can get close. And people were allowed to bring in outside sources of data and different things like that. So very, very interesting problem. That was kind of maybe one of the very first Kaggle problems. Anyway, if you go to Kaggle, you'll find one thing you'll find are lots of data sets. I know early on, I think Rakesh, you probably remember, we used a Walmart data set to test some of our early retail prediction ideas. But what I did was I went and I found a data set of customer service, IT ticket emails, and it looks kind of like this. And you can see on the left-hand side is the subject line of the email. The right-hand side is the body of the email. And there's lots of kind of funny characters here. Those are the 2 byte characters for languages that have funny characters that aren't present in English. They get interpreted correctly inside the LLM, but when we're just displaying them in Excel, I didn't have the right UTF encoding or whatever. So they look a little bit weird, but this one's in French, this one's in English, this one I'm thinking is Portuguese. Sometimes it's tough to tell between Portuguese and Spanish, but there's usually a few clues. Anyway, this is what we're given. Now, actually, the real data set has more columns in it, and it has the correct priority, the correct incident type, and the correct categorization. But I'm holding that back for now because we'll use that later uh, to judge how good of a job that we've done. So in the first week, I'm just going to give you this stuff, and then we'll play around with uh, coding so that we can do some of the deciphering, language translation stuff. I've got some homework assignments for you to fill in some of the other pieces, and then next week we'll look at making more of maybe a batch process where we can run through everything, and then we can start comparing our predicted labels and prioritizations to what was actually in the data set, the real data set. So let me switch over now, uh, and I'll switch over to VS Code, and we'll start looking at a notebook. And again, I'll put this up in the GitHub. Just real quick, did people have any issues with getting to the GitHub or anything like that? Anybody have any problems there? I know a few got in there. So um, anybody have any problems there? No? Okay. Well, we'll continue to use that method. So today, you'll find when you get to the GitHub, there'll be a week 02 directory now, and that's going to have the IT ticket data in it. So that's what this is. If you want to use VS Code, you can actually install various extensions. Like this is an extension that allows you to read Excel files and display them inside of VS Code. So that's pretty easy. Then let's see. We've got our stuff from the previous week here, but we're going to look at our ticket triage notebook. then there's week 1. So week 2 has a bunch of junk in it. It's got a requirements. So again, just make sure when you set up your environment, you look at the requirements and you make sure that you've got all of the libraries installed that you need. So we're going to go through this as a notebook. Restart so that I've got a clean palette here. So what I like to do, I just put all my library imports up at the top. So we've got pandas. Excuse me. This is pretty much the primary data handling a library for Python. Basically, it allows you to read data in and treat it kind of like a spreadsheet internally. Request we saw last week, which has the HTTP stuff. I'm going to show you a different way to do things this week using an SDK instead of HTTP requests. And then we're going to use a random number generator down below. So I've got that in here. So then I have a couple, just easy helper functions here. One is just the ability to show errors and then exit the program. That's not that important here, but if you're running something like Streamlit, where you've got a UI going, Streamlit will just keep running. It'll give you an error and then it'll just keep trying to run. And so sometimes it's better just to kind of terminate things rather than continue to process with errors going on. And then I've just got a little helper function that loads a CSV. So all of our data set of tickets is in a CSV here. So I've just got a nice little pandas. This is the primary. This is really the only thing in here that does anything. It's going to read the CSV path, which we pass in, and it's going to put it in a pandas data frame, and it's going to return that data frame. Good programming practice is always to wrap things in a try and except. Anytime you're looking for files where you might have the wrong file name or something, and this will trap any errors and allow us to handle them elegantly rather than letting Python throw out a bunch of crazy errors that a user will be overwhelmed by. So we're going to handle, if the CSV is not found, we're going to tell the user it's not found and exit. If we have some other kind of an error, we're going to print that and show what it is. So just good programming practice. Whenever you're doing anything involving the outside world, always wrap it in a try, except, and handle the errors yourself. So let me just run this one, and we're going to run this one so that those are defined for the rest of the notebook cells. Now, if you remember last week, what we did was we set up a JSON payload, and we passed that using the HTTP requests. And that is definitely one very legitimate way to do things. I kind of prefer using the SDK. So there's I don't know, I find this to be a little bit of an awkward construction, especially if you've got lots of variables going on. You're going to have to use F strings and build up your string and use that. Using a SDK approach is a little bit cleaner, I think. There's lots of stuff that's built into the SDK. You can use retries. For example, if you're calling OpenAI, you may get kicked back and saying, sorry, system's too busy right now. Resubmit your request in a few seconds. Well, you can use the SDK, and you can tell the SDK to automatically do some of those things, so you don't have to program that in yourself. If you're doing the requests, it's a little bit more manual. You've got more control, but you've also got to do more work. So for most things, I think the SDK is a little bit nicer. There's also async support, so you can submit things and then go on and do other work, and then come back and check the responses. And when you use ChatGPT, one thing you notice is it streams the responses. So it kind of types out the responses as it generates them. With the SDK, you can actually say stream equals true. Now, inside of a program, probably not making a lot of sense to do that. But I think with the SDK, in certain cases, if you're building like a little mini chatbot, you may want streaming stuff. So what we're going to do is we're going to import. This is the SDK library, and it says OpenAI, but it's the OpenAI format. So it's the OpenAI protocol. Your local LM Studio follows the same protocol. Grok follows the same protocol. OpenAI follows the same protocol. Most Olama follows the same protocol. So by importing this, we can really use the same SDK on all of those providers. And then OS we're going to use, and then .env. So .env is where we load our environment. So remember last week I showed you the .env file. Load.env is just going to load whatever. You can see I've got that in my week 02 folder. I've got .env, so it's going to load that. I'm not going to show it to you because then I'd have to go invalidate all my keys again. So I think you can go back and watch last week's video if you're confused about how to do the keys inside the .env. But basically, that's where you're going to store your API keys for accessing the LLM providers. Then we're going to do just a little setup here. We're going to set up our client, and using this OpenAI protocol, we're going to set the base URL, and notice that I'm using Grok here, api.grok. And because I'm using Grok, I also have to supply with an API key, which is the Grok API key out of my .env file. So if you're going to use this code exactly, you're going to have a Grok API key. Again, free. I encourage you to use Grok. They're very generous. Uncle Elon is very generous with his compute power. So why not take advantage of it? Open Router works as well, but some models are free, some are not. Or you can use your local. Here I have all the code to do a local LM Studio instance. The only difference is the API key is just fake. It doesn't use a real API key. You just have to put something in there so that the protocol is respected. So then we have our actual function definition, and the header here is we're going to pass it the system prompt, a user prompt. We're going to tell it what model to use. And this, what this line here does, if you're not familiar with Python, this will use this as a default. So if we do not pass a model name in, it'll default to GPT OSS 20B. Again, same thing here. We're going to tell it max tokens, how many tokens total it needs to deal with. I'm setting default here to 2000. I did some testing, and part of your token count, you have to think about, if you're going to use a high reasoning, you have to have enough tokens for it to think. So it thinks in tokens. So it's gonna write itself notes as it thinks. So you have to have a larger token space, a larger max tokens, if you want to use higher levels of reasoning. Some of the things you'll see, we're only returning one word or a few characters, but we have to understand that the max tokens includes how many tokens we're passing in, how many tokens we're getting out, how many tokens are used as thinking. Might have to experiment with this a little bit. You'll notice if the token count is too small, you'll see truncated responses or no response because it's used up all of its tokens thinking. Temperature is another one. For something like this, we want to keep the temperature low. So temperature is essentially a parameter that gives it a degree of variability, how much variability it has in choosing the next token. So the lower the temperature, the more it's going to slant towards choosing the highest probability next token in the prediction. So a very, very low or zero temperature, it'll always choose basically the same high probability token. If you set a high temperature, it will allow it to choose from a larger range of tokens as the next thing it does. And if you go really high, up around or above 1, you'll start to get some crazy, let's say very creative responses that you would not expect. So since we're doing something that is kind of precise. We want to keep the temperature low. If you're trying to create a kid story and you want dancing elves on the moon, you're probably going to want a very high temperature to give it room for creativity. So a new parameter that's kind of come on the scene with these reasoning models is the reasoning effort. You have to go look at the model card to see what if this is implemented, and if so, what strings it will take. I actually did a little work on this and I got actually two completely different answers. And I had to go to the model card and find that what it responds to is uh, um, default, low, medium, high, or none. So we're going to default it to low because most of the things we're going to do today don't require a lot of thinking. Language translation is very intrinsic to what LLMs do, so we don't need to do a lot of reasoning. So then I do a little this is a documentation string, and so this will a user who calls this routine further down. I'll show you how that shows, but it documents what all the parameters are, and then again we're going to use our try and accept, and we're going to call the model with the system prompt, the user prompt, all the parameters that we've done. We're going to return the response back to the program. So I'll just going to run that. So that's defined. So that's our LLM call wrapped in a little function. Now we can actually run our load of the CSV file. And if I hover over here, you can see the document string from load data. It tells you exactly what it'll do, what it expects, what it returns. So it's good practice to provide this documentation string so that later on in the program, you can see what that function actually does. So we'll just load this. You can see it loads pretty fast. And since we're in a notebook, I can actually just type in DF, and it'll give us a little bit of a selection of the head and the tail of the data frame. You can see there's 3,998 rows with 2 columns, subject and body. So now that we know what the data looks like, we can buzz down. What I'm going to do is use our random number generator. We're going to pick a ticket at random, and we're going to show, and this looks very much like Portuguese to me. So now I'll just run this real quick. This will call the LLM, and all it's going to ask is that it determine the language. So let's deconstruct this just a little bit. I created a system prompt. You're a helpful assistant analyzing support tickets. I don't need this in here. This is another way to specify the reasoning level, but using the SDK is more precise. Then we have a user prompt, and again, we're kind of building this up. So analyze the following support request email and return only the name of the language it is written in, and return one of the following languages: German, English, French, Portuguese, Spanish, or unknown. I like to use these little hash marks to separate out different areas of the prompt. I don't know that it's strictly necessary anymore. This used to be kind of a real back in GPT 3.5, it really responded well to these. I'm not sure it makes the big difference anymore. The LLMs are better at picking things out, but I like to use it even just for myself. Here's sort of the body of the work, right? Here's what I'm referring to. Analyze the following support request email, and kind of this signals to the LLM, here's the important stuff. And I'm just pulling the subject and the body out of the ticket number that we chose randomly here. So this ticket number, we're just using that ticket number to pull that out. We pack it into the prompt. And again, we just remind it your response should be simply one of these with no additional commentary or characters. If there's more than one language present, choose the predominant one. Now, a lot of Europeans will say hello. They'll say dear team. They'll write a couple of words of English, but then the body might be. We don't want to get confused. We want to choose the predominant language. And here's our call to the SDK. Again, if I hover over this, it's going to show me the function definition, all the arguments that I defined above. It's going to return the assistant's reply text. It stops on errors. So this is all from that little piece of documentation I did above. So it's really nice and handy. A lot of times we're going to take all those little helper functions, we're going to put them in a library. So they're not going to be easily visible to us. So having the little documentation strings handy makes life a lot easier. And notice I did put in max tokens. I put in the model name. I can switch the model name here. In this system, we're going to be calling LLMs repeatedly for different purposes, and we may choose to use different models. If a smaller model works, it's cheaper to call and faster. So we get an AI response, and we just do a little bit of, we make sure we strip any white space out of it. We turn it all to lowercase characters so we're consistent. If there's no response in there, we're going to put in no response in all caps so we see that. That would indicate typically there's a problem, something went wrong in our call. Maybe we had the token count set too low. So this is actually, we could cut this out now and actually paste it into ChatGPT and test if we get anything different. So this is the literal user prompt that we're sending to Grok, and this is what we got back. Okay, so pretty straightforward. I don't think there's a lot of mystery there. So now basically I took and cut and paste, I copied that cell, and now we're going to do a different thing. We're going to do a translation. Your job is now to translate support tickets from the original language to English. Remember up here, we said the language code was the response. So we can use that down here and we can plug that into our prompt. We can say, translate the following email subject line from whatever language code was detected up here to English, adapt it to American idioms and phrasing so that doesn't sound weird and stilted. And then we give it the subject line. And then your response should simply be the English translation with no other information. We don't want it putting any kind of weird JSON stuff in there or going off on a tangent explaining why it translated the way it did. So we'll run that real quick. And again, here's our translate this subject line. Here's the subject line. It picked up the fact that it was Portuguese. And here's the subject line, high priority issue with a JIRA update. Pretty straightforward. Finally, for our next trick, we'll do the exact same thing. Again, I just cut and paste. And this time we're translating the body, the email body, basically identical to what we just did. We'll run that. I set the reasoning effort to medium. I don't know if because it's a bigger translation, you may have noticed it seemed to take just a little bit longer to run. And then here's the full translation. Dear customer support team, I'm writing to urgently request assistance with a critical issue we're experiencing. So lots of detail here. So this will be what we feed in to our prioritization system, to our categorization system, etc. So that's where I wanted to get to today. The notebook will be in the Git, and your homework is right in the notebook. Going to add a cell to classify the tickets into 4 types. You're going to add a cell to determine which queue it goes in, and you're going to add a cell to determine the priority of the tickets. So if you go back in the slides, you'll see that I wrote out all the rules for prioritization. Your goal will be to use those rules. I actually have got I've got this sketched in, but I'm going to take that out and make you guys do it. So give this a try for next week, and ask any, during the week, feel free to send any questions my way. If you run into trouble, please ask questions. I'm online, all the time. So if you have a question through Teams, I'll be happy to answer it fairly rapidly. So that's where I wanted to end today. We almost landed exactly on the hour, so I get a pat on the back for that. And that is kind of where I'm going to leave things for this week. So I'm happy to hang out. Class is done, but I'll hang out if anybody has any questions. Please feel free. I'll hang out for a few minutes. Otherwise, I'll watch you all shuffle out of class, and when I'm the last one, then I'll shut the session down. And Rick has the link, then I'll post that in the various teams as well. So thanks, guys. Have a great day, and again, have a great weekend. Let me know if you have any questions.
Appreciate it, Tom.
Thanks, Tom.
All right.
Thank you.
Thank you so much.
you.
Thank you, everyone.
Bye, everyone.
Hey, Tom. Bye, everyone.
Thank you, Tom.
Bye. All right, guys, unless you two have a question, I'm shutting her down.